Hey there, fellow science enthusiasts. Today, we are diving deep into the fascinating world of neutrinos and their role in revealing Earth's hidden secrets. Get ready to explore the depths of our planet's mantle and uncover how these elusive particles are changing our understanding of our world. First things first, let's talk about neutrinos. These tiny particles are the most abundant mass-possessing particles in the universe, but they're incredibly elusive. They barely interact with matter, making them incredibly hard to detect. Despite being produced in the sun and passing through our bodies every second, we've only managed to capture a few 100,000 of their precious flashes. But here's where it gets even more intriguing: geoneutrinos. Geoneutrinos are the elusive cousins of regular neutrinos, produced by the radioactive elements that power Earth's tectonic heat engine. These elements, like uranium, thorium, and potassium, heat the interior of our planet, driving the flow of rocks in the mantle and shaping everything from plate tectonics to Earth's magnetic field. By counting geoneutrinos, scientists can get a direct measure of these vital heat-producing elements. Now, let's talk about the SNO+ experiment. This massive detector, buried deep within the Creighton mine in Canada, is designed to catch geoneutrinos. It's a house-sized marvel filled with 780 tons of oily liquid scintillator, which flashes when lit up by energetic particles. The surrounding water and rock shield the detector from cosmic radiation, allowing the flickers of less common particle interactions to shine through. The first detection of geoneutrinos was made by the Camland instrument in Japan in 2005, and the Borexino detector in Italy reported catching several dozen more in 2009. SNO+ made its first detection in November 2025, adding about 50 more to the count. What's truly remarkable is that these detections are happening in the Western Hemisphere, offering a new perspective on Earth's radioactive interior. But here's where things get interesting. Geoneutrinos could reveal differences between the areas of the mantle below each experiment. Geochemists have assumed that radioactive elements are evenly distributed throughout the mantle, but the measurements of geoneutrinos in different locations suggest otherwise. The regions producing the most geoneutrinos seem to sit above continent-sized blobs of anomalously hot, dense material known as large low-shear velocity provinces, LLSVPs. One LLSVP is under Africa, and the other is under the Pacific Ocean. This could indicate that there are deep Earth structures in the mantle that we don't fully understand. Neutrinos might offer new insights into the origin of these structures and the broader patterns in the mantle. However, there are significant uncertainties in interpreting these results. The outstanding question is whether the geoneutrino measurements reveal differences between the areas of the mantle or if the imbalance originates in the way the experiments count their geoneutrinos. It's a complex puzzle, and scientists are still working to unravel it. The future of geoneutrino research looks bright. The Juno experiment in China is expected to report its first geoneutrino flux later this year, adding a fourth and notably richer view. With its massive size, Juno is projected to detect more geoneutrinos in its first year than the combined output of Camland, Borexino, and SNO+ over decades. But the ultimate goal, as far as I'm concerned, is to build a neutrino detector at the bottom of the ocean. This idea has been championed by geochemist William McDonough for decades. An ocean bottom detector would be far from continental rocks, which are rich in radioactive elements, and the oceanic crust is thinner and more uniform. This would significantly reduce crust-related uncertainties. However, the idea of an ocean bottom detector is still a long way from becoming a reality. It's estimated to cost hundreds of millions of dollars, and government funders have been slow to take it up. But McDonough is hopeful that he can make it happen in China, which has given the green light to other big geoscience projects. In the meantime, physicists will continue their quest for answers deep underground. The mysteries of Earth's mantle are vast, and neutrinos are our key to unlocking them. So, stay tuned, and let's keep exploring the wonders of our planet's hidden depths.